They are in series, no? So directly, so instead of using any formula, so directly take help of this one. Q naught is equal to plus C1 minus Q naught by C1 minus Q naught by C2 minus C2 equals 0. E1 is 6, Q naught 2, Q naught 4 minus 2 equals 0. So this will be 4, Q naught 6 by 8. 32 by 6, 16 by 3 coulombs. Keep it here. So there's a one data. Now let's close the switch.
Sir, that is plus E2, no, sir.
Which one?
First equation, plus E2.
Plus C2.
Yes, loop equation, plus C2. So 8, it will become 8, no? Then
32 by 3.
64 by 6. How much? 32 by 3, huh? Okay, thank you. Yeah, no. After this, I'll close the switch. The switch is closed. What will the charge in them? Let it be different. Q1 minus Q1, Q2 minus Q2. So what should be the Q1? Q1 should be equal to C1 E1. It's straight away from here. We'll find out the next part. Q1 equal to C1 into E1. C1 is 2 into E. So this will be 12 coulombs. Q2 equal to C2 into E2. This will be 4 coulombs. 2 into 4, 8. Okay, how to trace out the charge, the next part. So here I told you the bucket concept. Here it is what you have to bring. Look at the plate, positive plate of the capacitor C1. Q1 equal to the capacitor is directly connected across cell, no, and this cell E1 is what? Voltage source. So therefore, the potential difference across that should be equal to that of the capacitor, that of the cell, because how this capacitor is directly connected across the cell, no? So the potential drop across the capacitor will be that of the cell. Similarly here, the capacitor is connected directly across a cell. So the drop across that should be called applied EMF. Okay, now we got this one. So how to trace out? I'll look at the plate, positive plate of capacitor C1. If you want, you can give the name for the plates A, B. Let this be plate A.
Sir, sir, why is charge not conserved at the junction, sir?
Why it must conserve? First of all, why it should conserve? Need not know. You just wait for explanation. So this is plus at plate A. Very best problem. Just very core ideas again explained. So what was the initial charge of plate A? Q naught. Then let's assume that some charge pushed into it. Some charge is being pushed here. I'll assume like this, the charge. Charges here. So Q naught, some positive charge plus QA entered and it has become, Q naught and it has become Q1. So do we know QA? As we know Q0 and Q1, subtract that. So 32 by 3 plus QA, Q1 is 12. 36, 4 by 3. Similarly, we'll analyze for the plate B. At plate B, look at this. What was the charge? Minus Q0. Plus QB charge entered there, and it has become minus Q2. Q0. Q2 is minus 8. 8 3 ja 24, 24 6 by 3, 2 coulombs.
8 by 3, sir. 8 by 3. 8 by 3.
8 by 3, yeah. Plate B. Plate C will show it here only. Now look at the plate C. What was the charge? Minus Q0 plus Q0 initially. Equal to finally so some charge entered. No, I made some system. The moment I close with some charge entered, after entering charge, then they become minus Q1 plus Q2. Try to observe this. What was charge? Minus Q0 plus Q0. Some charge after closing says some charge entered, then it made minus Q1 plus Q2. There's only possibility here, no? Here. So can you conserve charge of plate X and Y? No, should not, no, because it is connected. So it is not an isolated junction. Are you getting no idea? I'm just picked up this problem. There is no this like sir, what about the charge of plate A and B? Because again this wire is there, no, because of this wire. That's why I'm just focusing only on the plates here. So there is no any isolated junction better because of this wire is present. Goodbye to that particular idea in this particular specific problem. So plus QC should be equal to minus Q1 plus Q2. Anybody value QC?
Minus 4 coulomb.
Minus 4.
Plus 4.
Plus or minus?
Minus.
Minus.
Minus. Okay then. These are the values is what I got it. Okay, now with this, what happens? So this is the one method of tracing out the charges. I think really it's a very troublesome for students to identify isolated, not isolated. So this is the one classic example of where no isolated junction is what we introduced here. How to get the heat generated. So we'll calculate initial energy of the system, UI, final potential of system, UF, then work done by the cells. So can we trace out how much of charge has flown through the cell E1, QA only, and what charge has flown through the cell B, QB only? Already we have values, no, with that, and here QB charge. You check it all, it will satisfy this equation. QB, QC negative, no, so it will, you have to change the action. Leave it just here. QC put negative, that one. So it may trouble you. Actually, the QC will flow in this direction here. The QC only will branch out. QC only will branch out here. The QC charge will branch out. Now let's come for the directly the heat generated. Work done, initial energy of the circuit. Work done by the cell E1, work done by the cell E2, UF plus H. This will be Q naught square by 2C1, Q naught square by 2C2 plus. What is the work done by the cell E1? It does positive work, the cell E1, because positive charge is leaving the positive terminal. Almost all multiple ideas are there in this question. Try to concentrate here. Huh? So what about work done by the cell E1? It does positive work, no? So you write it QA into E1. What about QB? Positive charge enters positive terminal. We got QB positive only. So positive charge entering positive terminal. So therefore this should be negative. QB E2 equal to finally Q1 square by 2C1, Q2 square by 2C2 plus H. Solve it later on. This is the heat generated. Okay, fine. So tracing out charges. So how to trace out a charge in every branch? Who is going to help it? Not cell. It's a capacitor which is going to help. A plate of any one plate of capacitor. Any one plate of capacitor is going to help you.
4/3, sir.
What? Like?
Heat is 4/3.
4/3 joule. Huh?
Yes, sir.
Let them everyone calculate. Why to? Huh? 4/3 somebody is telling, one of your friend. Okay, cross verify afterwards.
Getting 932/27, sir.
That's what check calculation.